Welcome to module 6, and this is also continuation of the design of general purpose industrial helical gear reduction unit, and this is part 4, the almost the concluding part. Now, this is the lecture number 27, where we shall go for design verification including the keyways. What we have developed so far, we have developed the sub assemblies of the input shaft, intermediate shaft, and next the necessary verification was for the keyways before going into the completing the detailed drawing of the gearbox, that means plan view, elevation, housing, etc., etc. So, in this lecture basically I shall discuss about the, first of all we shall make some comments on some assemblies, and then design verification of selected case, and then finally again we will look into the alteration of the design. Now, here I would like to mention again that in the design initially we considered when we started drawing the which is shown in the left hand side, but later to match with the week 4 lectures we reoriented the sub assemblies in such a way that it matches with the problem which we started solving, intermediate shaft solving in lecture 4. Okay. Now, if we therefore, if we concentrate on the figure in 2 which is given here, what we find here that say this is the input and it is in the clockwise directions. So, this means that the here this teeth is coming off, that means on this shaft load is downwards, whereas on the intermediate shaft load is upward directions, whereas here if we consider this one, again this one is the pushing, it is rotating in the anti-clockwise directions, this one pushing the output gears apparently towards the back side of the slides, and therefore, here is also force in the upward directions. That means, in the intermediate shaft both the tangential force are in the upward directions, whereas here it is in the downward direction on this shaft, and ultimately the output shaft will also be in the downward directions. Now, next we have almost finalized the design of these 3 sub assemblies. Only what we found that bearing lives in case of input shaft and output shaft, it was more than what was required. In intermediate shaft, the life of the bearings were almost double. So, we can rethink over that portions, but while we are designing the output shaft, it is also shown that the portion where the gear is hitting, the shaft diameter is just satisfactory. This is because of the reason that we have taken a material C40 and it is just without any heat treatment we have used there, and there then the question comes that whether the key what we have selected, that is also satisfactory for transmitting the torque, or we need to change it. So, in fact finalizing this drawing of the plan view, what we will do, we shall now examine the design of the keys. Now, it is very important that the key should be such that if there is any failure comes, or in other words, if there is overloading comes, then the key should fail than the gear, okay, or any other components. So, key is used, if we look into this, key is used to assemble the gears on the shaft, or at the output end the coupling to this input, sorry, this is output end, this is output shaft sub assembly is shown. Now, if we consider the failure of the key, first of all we should know how the key are fixed. Now, the keys are there are many features, many type of keys are used. Among that, most commonly used are the flat keys, and it is cross section is rectangular shape. Usually it is the width is more than the height, width is more than the height. So, this is the height is h, and say if we consider this one, this is the height which is given by h, and this is the width which is designated by w, and the length of the key. Now, next the question is that why we are using this type of key. Then if we think of the machining of the keyways on the shaft, then we have to think of that we have to make a groove on the shaft, so that we can put this key. Now, if we think the cutting process, there are two methods, or there are other methods of course, mainly two common methods. One is that we can use a end mill cutter, we can use an end mill cutter, and that we can say this is end mill cutter of this size, and this will move from this point to this point, and this groove will be generated. Alternatively, we can use a side and face cutter which will cut the groove, but you should keep in mind, to have the required depth we have to cut a more length in this directions and in this direction also, so that we can use a key up to this length, because this groove on the, if we make it by side and face cutter, it will be something like this, where this is the cutter diameter. Okay. So, but this, if we cut the keyways in this way, this will be not convenient. So, best thing, if this keyway on the intermediate position, then we should make it with the end mill cutter. So, it will look like that. Now, there are again, after cutting this keyways, there are two options. One is that we can put the key up to this point, not for the circular part. This means that a rectangular key, what we can put it there. Okay. But this is again there will be some gap, right hand side and left hand side. So, there are special keys are made for which, not special, these keys are also standard. These heads are rounded like this, so that we can directly put inside this groove. Okay. Now, this again in the chart, we will look into the chart for the keyways, or in other words, which is the product catalog of the keys. There the length is mentions, the length in case of this round head, the length is the full length is mentioned, whereas in case of rectangular, fully rectangular key, the same length is mentioned. But while we calculate the strength, then we have to consider this carefully. I am coming to this point. Now, another point I would like to mention, for all shafts the chosen keys are standard rectangular keys. These are called rectangular keys, also called parallel keys. All keyways are cut by end mill key slot cutter. Here that we have used end mill cutter. At this portion, of course, we could have used the side and face cutter also, but still it is better to cut this keyway also with the help of the end mill cutter. Okay. Now, keys are made of low to medium carbon steel. Say for example, C30, C20 is the mild steel, C30 means 0.3% carbons. It is medium low medium carbon steel, you can say. It is slightly stronger than mild steel. The philosophy behind it, that that key must be the material wise weaker than the shaft and the gear. Gear material usually alloy steel. So, definitely key will be weaker than the gear material, but if we consider the shaft is also made of medium carbon steel. Suppose if we take the shaft C40, then it is better to use a mild steel key or C30 of that level. C30 is that level, means 0.3% carbon. Now, the as I have mentioned, it is milled by end mill cutter. However, at the free end, side and face cutter can be used at this side. Already this is discussed. For gear or say coupling, hub slotting is done in to generate keyways. That means, when we are making the keyways in the hub, this is the hub. This is the hub, that means this is the, in this case this is the gear. When we are making the slot in the gear, then we are using a slotting process, because there the milling may not be possible. Special milling of course possible, but best way is we can cut this groove by the slotting machines. There are special cutter for that keyway cutting, and we can use that one. Now, the keyways are made in such a way, the half of the key height, that edge, will sit in shaft and other half in hub. Then this is quite interesting. If we look into this, say this figure, then in that case actually shaft is going like this. So, if we take half of the height h by 2 from this point, that means, if we make this is h by 2, then after cutting this groove, actual height of the key inside the shaft will be less than h by 2. On the other hand, on the same philosophy, that on the half it will be less, same geometry we would say. From the same geometrical point of view, if we make the half groove there, this will be more than the actual depth. So, what is there, particularly in shaft, the depth of cut is made a little more than the h by 2, so that we can have actual depth inside the shaft is h by 2. And then again half, it is also h by 2, but however, there is a clearance at the top of the key in the hub, so that by no means the stress come in these directions. There is no stress in these directions. This is very important, because if we make the total groove height is exactly equal to the key height, in that case if there is some error, then a stress will be here, and due to that there will be some clearance will be generated between the hub and the gear, whatever small it might be, this may generate, and this will be failure in torque transmission. There will be failure in torque transmissions. Now, if we consider then the failure of this teeth, failure of this key, then what may happen? One is that the area will be shear or there will be crash. I am coming to that. Before that, I would like to say that this is the force acting on the key. Now, if we say suppose this is the direction of the torque which is shown here, this is the direction of the torque, then in that case then definitely hub is transmitting the torque, or if we consider the shaft, the shaft is transmitting the torque, passing the torque to this, and in that case what we find, there will be this torque is coming from the gear to hub. So, there will be forces in the top side, inside the hub, and on the shaft it is the bottom side, bottom half there will be forces, and summation of these forces can be calculated by these equations, that is the torque divided by shaft radius, we will get the total amount of force. Now, if we look into the failure of the shaft, then it might be fail due to the shear. If the developed shear stress exceeds the allowable shear strength of the key material, then it will fail, and this failure is like this. You can say that due to this upper half and lower half, they will be simply shear out, and this is the common failure. This is the expected failure in case there is overload. Okay. However, the and this shear stress, if you calculate for this key with round head, then we shall consider this F k, and then we have to consider this full area, which can be calculated by, if this is the length minus W is the width into width, that means this rectangular area, and then one circular area which is calculated by this, that is the total shear area. Although the force are being applied at the middle, but we can consider that this is the average area which is being taken by the key. Now, in case if we use a rectangular key for which the completely rectangular in top sides, then the size of the key will be then size of the key will be this much. Although the groove is made with round head, but the size of the key will be this. Then in that case, the designated length by the manufacturer is this much. So, to consider that key, we have to consider the equation, this W will not be there, L into W, at the same time this area will not be there. That means, in that case, for that, if it is a completely rectangular key we are using, then F k, that is the total force, divided by forces on the key divided by the L into W. That we should remember. Depending on the key, we have to calculate accordingly. Now, again this key may fail due to the crushing. What is crushing? As the forces are acting in this way and this way, then the upper portion will try to be compressed, or you can say bottom portion will be tried to be compressed in one way and upper portion will try to be compressed in other way, opposite directions. Then probable failure, it might be like this. Say bottom portion, as it is sitting firmly inside the groove, whereas in case of the hub, the groove is like that. This end, other end is free. So, therefore, you may see this upper portion may slightly bulge out, maybe this will be compressed, this H will this W will be reduced, it will be compressed like this, whereas this length at the top will slightly try to increase, this L plus it will try to increase, and then the actual failure it may not be observed, but it is like that this half portion will become loose and there may have some micro cracks like this on top and bottom. So, that is called, that is failure due to crushing. Now, it is to be remembered for this material, any material, this crushing allowable strength and shear allowable strength are different, as well as the crushing area on which the pressure is there and the shear area, these are two different. So, we need to verify both. However, there is also another issue that is to be considered, that is called bearing strength. Now, normally if the key is verified for the crushing strength and the shear strength, we need not verify for the bearing strength because of the reasons, usually the bearing capability of the key is more than the crushing. Area for the bearing is also same as the crushing, that means this area, as you see here the formula, this is the same area. Okay. But what is this bearing? This bearing failure means the surface on which the load is acting, somewhat it fails due to the contact strength, not crushing, but the contact strength, and due to that failure means there will be that small pitting sort of things. Now, usually for this type of key this will not happen, but if we consider the spline is the another option of fittings where the hub length is small and one single key is not enough. Even if we put two keys, it may not be enough. Two keys we can put at the 180 degree or side by side. Okay. Side by side means on the shaft it can be put like this. Sometimes it is used like this, but these are very rare. Sorry, these are very rare. So, better to use only single K, or else we should go for spline. If you have the idea about the spline, splines are like that. On the half grooves are like this, and on the shaft also it is cut like this. It is usually done by broaching, and in that type of fittings it is not like this key, where this key here it is tight fit. In this case it is not tight fit like that, rather the inside of the inside spline of the on the half and at the root of the shaft they are matching. So, therefore, at this side, this means here there will be a small clearance, and due to the dynamic load, when this is coming over there again and again, then there is also possibility of the we should consider about the bearing strength, which is a different from the crushing strength. Okay. But anyway, it has been seen for the keyway, if it is not failing for the crushing strength, it will never fail due to the bearing strength unless it becomes loose. So, we need not consider checking this bearing strength for this type of keys, right. Now, the key dimensions which are shown here, a sample is shown here. Now, if we remember the input shaft we have kept 25 millimeter, and bearing we have kept there 30 millimeter, 25 millimeter, and output shaft the diameter we have kept 40 millimeter. So, here we have shown this table only from starting from 1720 to 5865, right, and so that we can select the key for either from here for the input, and for the output shaft we can take it from, say, this is in the range of 40, whereas where the gear is sitting it is 55. So, this chart is made like that as a sample. Now, what are the dimensions are given? The first of all, it is cross section. For example, the shaft diameter, if it is between 17 and 22, it is 6 by 6. That means, cross section is also fully square, but above that it is 8 and 7. That means, 22, 38 and 7, 8 is the width, 7 is the height. So, it is after that it is of that size, that means, width is always higher than the height. And if we look into the length of the key, then for say example 30 to 38, for this one we find 20 to 110. So, 22 is the smallest size and 110 is the, and in our design mostly we have selected the keys which is length usually not more than 40 and maximum it is the 60 millimeter. So, that will be available within this. Apart from that, what is more important dimensions, that on the shaft depth T1 is, say for example, if we consider the input shaft, on the shaft the height is 8 millimeter. So, h by 2 is 4 millimeter, but T1 on the shaft it is, say this one, it is, say this is T1, this is 5 millimeter, whereas on the half it is 3.3 millimeter. Here this is 3.3 millimeter, which is T2. Okay. And what else? On the key, say if we consider the key corner radius is 0.25, it may be radius at the corner or maybe chamfer also, which is R1 into 45 degree. Say R1 is 0.25. So, we can make So, in this case 0.4 and 0.55, that means either 0.55 into this key are made 0.55 into 45 degree chamfer or 0.55 corner radius. Sorry, it is R2, it is R2, not R1, it is R2, right, R2. So, key means this R2 is made 0.25 or in this case 0.45 of chamfer, whereas on the groove it is the radius. So, here this radius corner which is given by R2, right. So, that is 0.4 in this case 0.4 R, 0.4 millimeter. This means that the end mill cutter what we are using, the tip is having this 0.4 corner radius. So, that the key can safely sit inside this, and most importantly that there is a gap, this must be maintained so that there is a no pressure from the top. And many people make a mistakes that on the same area of the shear they consider that there will be the crushing load from the top and that they try to calculate, but this is not true. Crushing means this will be failure here and shear means the failure will be here. Now, so depending on the shaft diameter and others, we can select that what the key will sit on this shafts. Here we have taken input shaft is 30 millimeter and for which we find that 8 and 10, 8 millimeter is the height and 10 millimeter is the width, this key is put there. And the material of this initially we selected C30, but later we found that here if we take C30 then this may fail, as well as here also, particularly the output side that may fail. What we have considered that strength, allowable strength is for the crushing is 2 times less than the yield strength, okay, whereas here strength almost 4 times less than the yield strength. That is to take care of that severity of the operations, and either we can multiply this factor with the applied load, that means from nominal torque while we are considering for on which basis we are calculating the F k, there itself we can consider the load is more due to the severity of the operation, or in the allowable strength of the keyway we can consider that. This keyway I mean selects verification of the strength of the key and etcetera, that will be done through the assignments, but what I have verified in that case all the key sizes are being satisfied, but the materials should be at least C40. If we take the C40 materials there is no harm, because our 2 shafts, the input and intermediate shafts are made of alloy steels, the pinion material, the same material as in pinion, whereas in case of output shaft it is C45 and it is preheated before milling machining, before machining. So, this will have more strength than if we take the key material C40. Okay. So, this is the end of this lecture, and next we shall go into detailed drawing of the this plan view, and there we will reconsider the shaft size and the bearing if necessary. otherwise we can complete the design keeping all these selected bearings, keyways, everything unaltered. So, next lecture I shall go for the plan view of this gearbox, and there I will again discuss if there is any change, why we have made this change.